All right, we are back at it. Moving on to section 4.8, which is solving inequalities involving adding and subtracting. You learned about inequalities yesterday, and that means an inequality gives you a range of solutions. So for example, r is greater than 2 can be any number that's bigger than 2. So there are lots and lots and lots of numbers that satisfy that. Solving inequalities is going to be very much like solving equations, except instead of having just one answer that the variable could be to make it true, you will now have an infinite number of solutions. And again, that just means that there are lots and lots and lots of numbers that would make it true. But it's going to look very familiar because you are going to do the exact same process, trying to isolate the variable using inverse operations while following the golden rule. Let's take a look. Consider our first inequality. C plus 1 is greater than 5. Remember, a variable is just a letter used to represent a number. Well, you might start thinking about a number that could make this true. If C was 10, this would be true because 10 plus 1 is 11, and 11 is greater than 5. So C could be 10, and it would work. You could say that C is 20, and if you plug in 20 plus 1 is 21, which is greater than 5. You could plug in 100 plus 1 is 101, which is greater than 5. So I've thrown out 3 numbers that this could be, and I just picked 3 random numbers. The thing with inequalities is that there are so many solutions that you would never want to list all of them. You would never get done. So this is what you do. This is the fastest route to show all of the possibilities for your variable C. The goal is to isolate your variable C. So do the inverse operation to get rid of the adding 1 or the plus 1 or a positive 1. So to cancel that out, you would need to subtract 1. But whatever you do to one side, you have to do to the other. I'm going to draw a line just like we did with equations. This cancels out. However, this isn't an equal sign. It's not an equation. It's an inequality. It's 2 things that are not equal. So instead of an equal sign, I just drop down my greater than sign. That is the only difference. So then I'm going to drop C down because that's what I have left. And then 5 minus 1 is 4. So if you read this mathematically, it says that C is greater than 4. And if you look up over here, all of the solutions that I had come up with were greater than 4. Any single number bigger than 4 will make this true. Consider even decimals. If you plug in the decimal 4.5, 4.5 is bigger than 4, and if you add 1, you get 5.5. 5.5 is bigger than 5, so that decimal also makes it true. You might have a number that's a fraction. You might have the number 4 and 1/4. If you add 4 and 1/4, you get 5 and a fourth, and 5 and 1/4 is also bigger than 5, and we haven't even... we've just scratched the surface. Again, you would have to list so many numbers, you would never stop. So the easiest way to show your solutions is this inequality, and it just says that any number bigger than 4 will work. Now, the other part of solving inequalities is that you want a graph because it's very easy to see your solutions when it's on a number line. So when you do a number line, you'll hear us say that you need to have at least 3 points. And you want to make sure that they are evenly spaced. I put 5. And one of the ways, or a simple way to get started is to put that solution in the middle and then maybe go by ones. You don't have to, but if you go by ones. And then the other part of this, we talked about open circles and closed circles. If it says greater than, it means that it has to be bigger than, and it can't be 4. So since it can't be 4, I'm going to put an open circle, and then greater than is shaded to the right. So I'm going to shade my number line with an arrow showing that every single number to the right of this is a solution.
I'm back. This is Maddie. Let me show you 3 more examples.
Okay, I'm going to try to quickly solve these 3 just to give you an idea of 3 different types of inequalities. On the first one, d minus 11 is less than negative 8. The goal is to isolate this variable, so I am going to do the opposite of subtracting 11, which is adding 11, and I have to do it on both sides. It's not an equation, it's not an equal sign, so I'm going to drop my less than sign. I have d remaining after this cancels out, and negative 8 plus 11 is 3. So my inequality reads d is less than 3, which means any number less than 3 will make this true. So then I am going to graph it on my number line. It needs at least 3 numbers. I'm going to put 4. I am going to put 3 in the middle, and I'm going to go by 1. So that would be 2, 3, 4, 5. It is less than, so I am going to use an open circle on the 3. And since it's less than, numbers less than go to the left. 10 is less than b minus 5. On this one, I am trying to isolate the
B.
To isolate the b, you need to do the opposite of subtracting 5, which is
Adding 5.
You need to add 5 on both sides. So that cancels, leaving you with b, and 10 plus 5 is
15.
And it isn't an equal sign, it's a less than sign. So that reads as 10 is less than b, which if you would rewrite it, you would say that b is greater than 10, and then you graph it. Get your number line, at least 3 or 4 points on there. This time, just to show you that it doesn't always have to be the same, maybe I'm going to put 0 in the middle, and I'm going to go by negative 10, 10, 20. As long as they are evenly spaced, it's okay. I have an open circle on my 10, and I shade it to the right. And our final example is negative 24 is greater than or equal to r plus 4. Our goal is to isolate this r. The opposite of adding 4 is
Subtracting 4.
And the golden rule, whatever we do to one side, we have to do to the other. So the adding 4, subtracting 4 cancels each other out. So I drop down my r. It's not an equal sign. It's a greater than or equal to sign. And then I have negative 24 minus 4. You can think temperature, 24 degrees below 0, it drops 4. You're $24 in debt, you spend 4 more dollars. Or look and see there are 2 negatives, and when you add the same sign, when you have the same sign, you add them. So 24 plus 4 is 28, and it's negative. And again, if your variable falls on that side, rewrite it. If you put r first, I'm going to go back to the 2nd grade reference here. The alligator is still going to eat the negative 28, so you need to switch it. And this means that r is less than or equal to negative 28. So you make your number line evenly spaced. I'm going to put my number in the middle. And this time I'm going to go by 2's. So negative 26, negative 24. Be careful when you work with negatives. Remember, they go in reverse order. And I am going to put a closed circle on the negative 28 because it has that equal sign on the bottom. And we shade it to the left. And that's it, folks. That is how to solve inequalities involving adding and subtracting. And Maddie has one final word for you.
Have a good day.
Holy smokes, people. Go back and look at my second one. It is so easy to make mistakes. If you look here, I made the simple mistake because I was recording. I said 10, but it should have been 15. And Maddie even said that. So my answer should be B is greater than 15. So my number line should have started at 15, which is right here in the middle of 10 and 15. Should have been an open circle on 15, shaded to the right. I am sorry about that.
I mean it this time. Have a great day again.